All right, hello everyone. Thank you for joining us for the webinar today, orchestrating trust in your DevOps pipeline. We have a lot of content to go over, but I would like to do some housekeeping and items up front. I just want to let everyone know we are recording this, so the slides and video will be made available later on. We are also able to take questions. You can ask them in the little questions panel. Please do at any time you have a question. We may not have time at the end to get to all of them, but we can take them offline. So don't be afraid or think that yours won't get answers. Please still submit it. I do want to start off with a couple of poll questions for everyone, just to kind of get an idea of who we have in the audience, so we kind of have the presenters have a better idea of how to explain things better. These first two are going to just be for us. So I'm going to leave this up for about 30 seconds or until about 75% of you have voted. We will not be publicly showing the results, so be honest, and we will look at it after the fact. Votes are coming in quick. I like it. I'm going to give this about 5 more seconds, it looks like. 3, 2, 1. All right, thank you. And now one more, same thing, just to give us an idea on the back end of who we're presenting to. Again, votes are coming in quick. I love it. We're already at a pretty good percentage, so let's give it another 5 seconds. 5, 4, 3, 2. All right. Now for everyone, I have 2 final poll questions so that all the presenters can get a real good idea of how we are here. Results are looking great so far on this one. All right, give this about 5 more seconds. 5, 4, 3, 2. Just for everyone to see, with is DevSecOps important to your role? We have 57% with yes, 40% getting to be more important, and only 4% for no, which I think is very telling of how things are in the field. So let's do one final poll question, and then we can get started. What are the main challenges you're facing with security and DevOps? There we go. I'm excited to share the results from this one. It's very even from everyone so far. All right, we're going to give this about 5 more seconds. 5, 4, 3, 2. All right, so the main challenges with security and DevOps, as you can see, pretty even spread, which is really interesting to see. So 31% understanding threats, 18% tool sprawl, 30% on-premise and cloud, and 21% changing priorities. All right, thank you for participating in those. I will be putting a link to a survey later on during the Q&A in the chat window, which will also be in the follow-up email, just so we can get a better idea of how you enjoyed the webinar and what kind of things you're looking to hear next. In the meantime, we should get started because we do have a lot of stuff to cover. So I would like to pass off to our first presenter, which is Kathy Lamb from CloudBees. Kathy.
Great, thanks so much, Max. Welcome, everyone. Good morning, good afternoon. I'm pretty excited because we have 2 great speakers that we're bringing in from CyberArk, Joe Garcia and Dan Warner. Just a quick intro to myself. I'm product marketing manager at CloudBees. I've been here about a year, and prior to that, I was both in the DevOps as well as in security space. And so, Joe and Dan, would you like to introduce yourselves?
Sure, yeah. My name is Joe Garcia, and I've been with CyberArk for about 1.5 years, going on 2 years now, but was a customer for them before I came to work here. I've been doing automation for about 5 years and do automation for them now for the company. So I'll be talking a little bit about the policy that we'll be looking at today and demonstrating that.
Yeah, so my name is Dan Warner. I'm on the product management team at CyberArk. I've been here for about 5 months. Prior to this, I was at a company called Conger, which was acquired by CyberArk, where we were focused on building security solutions for continuous delivery and for cloud migration projects. And I've been doing cloud computing and from a security aspect for about 10 years, and you know, I'm excited to be a part of the CyberArk team and to have this conversation, have the opportunity to have this conversation with all of you.
Jeffy, I believe you're on mute currently.
I was. That was embarrassing. So yeah, actually, Dan, thanks, and Joe, thanks so much for the intro. What's been pretty exciting is that this presentation is a culmination about a year's worth of work, where it was actually some of our joint customers that had asked us to create an integration between CyberArk and CloudBees. And so with that, I'm not sure if everyone who's attending knows about CyberArk. So Dan, if you could just talk a few minutes about CyberArk, and then we'll go ahead and get the presentation started.
Yeah, absolutely. So, so if you've been involved in enterprise security for any amount of time, you're probably familiar with CyberArk. They've got a really strong brand when it comes to security teams. They've been around for about, you know, since the 90s. They've got a huge footprint. If you know, if you work at a bank or some other highly regulated industry, you know, healthcare, then there's a good chance that you're a CyberArk customer. You know, as I said, it's exciting to have worked for a startup and be brought in to the CyberArk family, because, you know, they really have a great reputation with security teams. From an operations and DevOps and standpoint, you know, you may not have heard of CyberArk, because it just hasn't been, you know, a fundamental part of that space. So a lot of the DevOps tools and the DevOps environment sort of like grew up, you know, adjacent to CyberArk. But here's the, you know, this is our opportunity to start bringing those two worlds together.
Great, thanks so much. And then just a quick intro into who's CloudBees. I think everyone on the call knows about Jenkins, about the open source automation tool. And so CloudBees is the company behind Enterprise Jenkins. And one of the reasons why Jenkins is so popular is probably because of the number of integrations that we have with all the products that developers like to use. And so it's really this flexibility that you know, makes our solution really powerful. So what I'd like to go ahead and get started is, like, why is DevSec Ops such kind of an exciting topic these days? And unfortunately, you know, if you've been aware with the news, there's like breaches like Equifax, Target a couple years ago, and so the average cost of these breaches is fairly high. But I wanted to look at what were the odds of that, you know, you inside a company of getting breached by an attacker. And so I think there, you know, people hear about odds about like the chance of winning a lottery ticket, chances of, you know, getting struck by lightning. But I thought it was rather interesting that in the study that Ponemon published every year, that now the chances of data breaches is about 28%, which is relatively high, right? Because it means basically in your lifetime, in your career, your company is going to have a breach. And so the question is, you know, what can we do to stop that from happening? And so that's why, you know, when I said earlier, this project that CyberArk and CloudBees has been working on, it's really to help enterprise companies, you know, secure their DevOps pipeline. And most large companies, when they're looking at adopting a solution or a tool for the DevOps processes, they're looking, to make sure that it can scale, that the tool is manageable, that it can go out to hundreds, if not thousands, of users, and most importantly, that it's secure. And so what we've done here is created a solution that helps meet the needs of large companies. And if you're a company that has to manage passwords for a bunch of different tools, this is why it's so exciting, because we're focused on helping companies become successful in their software delivery lifecycle, and making sure that passwords and secrets management is much easier. So with that, in doing some of the research to put this presentation together, we looked at Forrester and Gartner, and it turns out that there's still a lot of challenges for development teams to really go as fast as they can possibly go. And one of the reasons is kind of a cultural challenge between the two teams, which is the development team and the security teams. And if you can think of it as kind of their mindset, it makes sense, right? A developer is focused on how do you iterate as fast as possible, how do you deliver value to your customer, how do you make software that's maintainable and can scale. Whereas the SecOps team, they're focused more on how do I make sure that everything that we're doing falls under the security policies and guidelines, and how do you make sure that it passes the audit checks? Because if you're a public company, you need to go through audits every couple of years, and you want to make sure that your company is protected. And so that team is focused more on making sure that the changes don't actually impact the company. And so as developers are trying to accelerate change, and the security professionals are trying to make sure that the changes don't actually cause outages, there's a difference in priorities. But when you look at it, it's really the same. It's really the same. They're in the same team, because they're serving the same customer. And so what we're trying to do is actually create a solution that enables both teams to do what they need to do and get out of each other's ways, right? And so, security teams are used to trying to make sure that the projects that developers are working on, are compliant with the policies, and developers are focused on using tools that help enable them to go faster. But what's challenging sometimes is that a lot of the policies are written in such a way that it's easy for a machine to understand, but not easy for an auditor to be able to quickly go in and check to make sure that it's compliance. And so what we're trying to do is create a solution that makes it easy for both teams to get the job done. Okay. And so when you think of it from a developer's perspective, developers trying to get their code out into the customer's hands as soon as possible. In order to do that, they need to go through a varied number of stages and go through different servers. And each of these tools require a different login. And so, just earlier in the year when I was trying to set up a demo for one of the conferences we were attending, I was working with some of the developers, and we were exchanging passwords in Slack. We were copying passwords in Notepad, and it becomes quite difficult. And you can imagine, even in your day-to-day life, if you're looking at all the different accounts that you have, if you don't have something like LastPass, it really becomes a nightmare to be able to manage all of these different tools together. And what makes it even more difficult is the fact that it's not just access to different tools, but access to different servers that are now being brought live, for a go live, and you could have virtual machines popping up and having to create identities and passwords for all of these machines. It becomes very challenging, and so we need a solution that's easy to manage. And so CloudBees has always been focused on how do we make it easy to help security teams and as well as Jenkins admins be able to create role-based access. And so we've worked on making our operations center easy to be able to delegate control to team leads by using policies and being able to connect with systems like Active Directory and LDAP, so that it makes it easier for users to be able to manage Jenkins installation. But then, as we look at all the different systems that Jenkins works with, there isn't an all-encompassing tool to make this simple to manage. And so, what we're trying to do here is help developers as well as security teams work better together. And so, with that, I'd like to pass over control over to Dan to see if you'd like to continue this as well.
Sure. So thanks. I like this slide a lot. Like when you first look at it, it's like, okay, this is a lot of information to squeeze onto one slide, and we've tried to reduce it sometimes, but there's a couple of things that I really like about it. One is it does start to show the exploding complexity of not just tooling, but the process. And from the poll, I saw that people are interested in this this idea of tool sprawl, and this starts to hint at it, right? And the other thing I like about this slide is that it was built by a security person. So it's when you look at the continuous delivery pipeline from a software development standpoint, it looks pretty simple, or CloudBees has done a great job in simplifying it so that it makes sense. But when you look at it from a security person's point of view, you can see that they have a lot of concerns, and this is for all the tools and all the stages of the process, what they're thinking, the concerns that they have on their mind when we start to talk about the CI/CD pipeline. You'll notice that this is very different from a developer's point of view. And you'll also notice that it's not just about protecting secrets, which has really dominated the security conversation in DevOps up until recently. Of course, managing secrets plays an important role, but every new tool, every new stage in the process introduces new risks. And when you start to design ways for your team to work together to manage those risks in a way that satisfies IT security fundamentals and audit requirements, you'll notice pretty quick that there's a lot of work to be done, and it's not just about managing secrets. And if there's anyone listening to this that has ever had a packet of audit findings dropped on their desk, this isn't news. And speaking of that, where this stuff really has teeth, where these security concerns really have teeth, is when you're trying to move your project, your system into production, or when you've been successful in one area of the business with automation and you want to either run it as a service or expand it out to other teams in some ways, and then you really have to start to address some of these security concerns, or else your growth is going to be constrained. So there are a lot of brilliant automation projects that are sitting on the shelf that have been delayed or stalled out because of this stuff. So good slide. Can we go to the next one, Kathy? Cool. So what do we do to solve all of this complexity? And again, from the poll I saw, what are the actual risks that we're facing? Some of those risks from the previous slide are real, and they're they're ever present, but some are, are maybe less real or can be solved by addressing other aspects of the system. So the first thing we got to do is pull back a little bit and look at what aspects of this pipeline are producing the risks. We've been working with security teams and development teams for a few years now, and this is really how we consolidate the problem. So first is the unmanaged secrets and credentials, right? Everyone should be familiar with this at this point. From a security perspective, this isn't just about managing people, because a lot of privileged activity, a lot of privileged accounts reside with machines now. And a machine could be a container, a script, an application, anything that performs a privileged action. And anywhere there's an app, no matter how it's built, how it's architected, if it needs to do something, it's going to need a credential to do it. And so this leads to a lot of bad practices, secrets being shared out of band by developers, baking secrets into images, secrets leaking into log files, all of that stuff, but also, just no security fundamentals around your secrets management, right? So no rotation, no encryption, no least privilege, So yeah, that's a big problem. Second part, the master servers with too much privilege. So this takes a second to explain here, but a very common pattern with an automation tool is to have some sort of master server that distributes configuration to slave servers, or in Puppet it's called Puppet Master and Puppet nodes. In Ansible, there's the Ansible control node. And this is the idea here is to be able to automate, so you could distribute configuration to these subordinate nodes. But what we're seeing a lot of is these master servers have privilege to suck data out of whatever sort of secure secret store you might be using, decrypt it, and then distribute it. And this is really a problem of overprivilege, right? If you have one sort of high value target like a master server that has privilege to that level on a secure secret store, then that secure secret store is not secure. So cleaning up this model a little bit is really something that needs to happen. So the third piece, like duplicating secrets management functionality, so for different platforms. So you're able to get your CloudBees. So CloudBees has done an awesome job in making some secrets management functionality baked in. In fact, they're way ahead of the game. Other DevOps tools are starting to catch up, right? And they have some native secrets management functionality that allows them to operate securely. But what happens when you have 2 or 3 of these systems, like we saw from that craziness slide? You don't have one platform. You've got many platforms, and they all have to work together. So what ends up happening is you are able to achieve success with one platform in terms of secure distribution of secrets and least privilege and all that stuff, but then it's hard, maybe impossible to scale that across all of the different tools that you're using. So you end up building a lot of bespoke solutions. It's not good. Last one, lack of audit visibility. Visibility, very squishy term. I know a lot of, when you're marketing security products, this term comes up a lot, but here it is key, because the usability of DevOps tools, when it's constrained to DevOps operators or our operations personnel, and there's no on-demand access for security personnel, then that's not a secure system. The way I usually talk about it is, I say, if the first step to solving your problem is go find someone who knows how to use the system, well, then that system's not secure. Your access needs to be on demand. And for most compliance strategies, you're going to need to make security trade-offs, right? If you're defining your strategy, or if you're seeing if a proposal meets a certain the criteria for a certain compliance control, then you're going to need visibility into that, and it can't be contingent on getting a report from someone who it may or may not be out of date, it may or may not be complete, it may not be focused on exactly the thing that you want. So visibility, especially in terms of audit, very key for this. Okay, I think we can go to the next slide. So I know nothing gets your point across better than a wall of text. so that's the approach I've taken here. But this is how you go about addressing some of these challenges from a high level, right? So the first three are really about security as code, which is something that you're probably familiar with, especially if you've been working with CloudBees for a while. And that is how do we solve some of these issues in a way that can be interfaced with on a machine level? It can be versioned, it can be collaborated on, and you know, security as code. Actually, I won't go into it all now, but you know, I think that's a concept that's key to this and worth investigating if you don't know much about it. So for the unmanaged secrets and credentials, you need a collaborative policy format. And this means that you have a way to manage secrets that works for developers when they're in their development environment, and it works for operations teams when they're in a more sensitive production type of environment. So you think about it, you know, you keep the same structure in terms of a policy, and that policy moves with the code through these environments, dev, test, prod, and it keeps the structure, but it changes the values, and who manages those values changes per each environment. So actually, Joe is going to get into a demo. He's got a great demo on policies, so I'll leave it at that. But that's really the core of managing secrets. Master servers with too much privilege. What do we do about that? So machine identity and role-based access controls. There's really no shortcut for this. You can do it in automated ways, and that's what Conger really specializes in. But you have to assign identities to everything. You have a VM, you have a container, you have an application, a pod, a server, a job, a service, right? These things need identities so that you can apply policies to them, role-based policies, and that will allow you to pull back and manage these things at scale. And it'll also fit into, you know, the first point, which is you have code that can or you have a code-based system that can travel through the development process. And by doing that, you push, you know, you would set up a policy model that pushes authentication and authorization down to the node level, or even more granular, depending on what it is you're trying to do. So duplicating secrets management functionality, by building a common interface, right? So we have an open source project called Summon that we use to do this. We also have, CyberArk has a product called AIM that they use to do this, and this is basically a common interface, no matter what tool you're using, that you're able to you know, get what you need when you need it from a secure, authenticated, audited storage place, right? And any platform that you use to do this obviously needs to be highly flexible, so that you can build out your own integrations with whatever it is that you happen to be working with, right? So you can scale it, you can knit it into your infrastructure, but really the idea of laying over a common interface for this stuff, at least in terms of a model for how secrets should be injected into processes or given to different machines. It's important. A lack of audit and compliance, on-demand access to reports and policies. Again, no real shortcut here. Actually, what we've seen is that a lot of larger organizations will build their own reporting layer over tools, and that's good, but it actually doesn't get the whole job done. Some level of native visibility, native reporting functionality needs to exist, you know, in a place that's accessible, but also close to the tools that it's reporting on. So we focused a lot on building out some native report functionality, and that's a direction that we continue to go in. Why don't we go to the next slide? So, okay, this is a partial view of how CyberArk and Conger work with CloudBees. Conger is usually deployed as a Docker container. It has a highly available architecture. It's designed to scale up and down to meet demand. What it's doing is working with CloudBees to assign these machine identities, not just to the master, but to the slaves, and once everything has an identity, they can call out to Contra to authenticate. Right? Contra will check to see that, in this case, that that Jenkins node is authorized to have access to the secrets it's requested, and that it'd be based on a policy. And if it does, they could use the open source tool called Summon that I already spoke about to inject secrets directly into these jobs. The added benefit here is that Contra can also interface with some of the more trusted business systems, some of the things that security teams are more used to using, like Active Directory or some other LDAP directory, and CyberArk itself. And Contra has integrations built out for all the major DevOps platforms now. So no matter what it is that you're using, you're able to work in a way that an operator of that system would expect. So it's important to us that someone who's using CloudBees doesn't feel like there's this alien workflow now that has to come in and be another thing that they've got to set up and maintain. Right? It's important that we work in a CloudBees-y kind of way. Just like it's important when we work with Ansible or when we work with some of the container orchestration platforms that we work in a way that the integration doesn't totally disrupt the workflow for the operator. Yeah, that's it for that. I think we could go to the next one. Oh, good. So it's demo time. So Joe's prepared a great demo. Like I said, I think it focuses mainly on policies, but I'll just let him jump right into it. I know that he gives a lot of great context to it too.
Yeah, thanks there, Dan. So again, my name is Joe Garcia. I'm the automation guru with CyberArk. I'm going to ask everybody real quick just to take a screenshot of this title screen, because I do have a couple links up here. I've got a GitHub link, a GitHub page link, as well as my Twitter handle. And I kind of want everybody to sit back and relax and enjoy themselves for this presentation, because it's going to get a little in-depth and it's going to get a little crazy. But it's a new concept. It's policy as code, and it's the direction of the future. So I really want everybody to pay attention. And then I've put it up on GitHub in an open source format so that you can then go over it at your own pace, on your own time, and relax and kind of go over what I'm going to show you today. So first, we're going to go into what a security policy is, because I don't assume everybody in the crowd is a security a person or worked in security or InfoSec in the past. I'm sure most are either a developer or in operations or something like that. So we'll talk about what a security policy is in the past and the present, so that we can understand what policy as code is going to be for the future, and how we use it in Conger today, along with our role-based access control to effectively manage secrets access, as well as to be able to audit the activities that are happening on those secrets. All right, so like I said, it is on GitHub. It's available on that screenshot links that you took. And then I do have a way for you testing it utilizing CyberArk's Conger Community Edition, which is our open source version. I've got a cool Docker Compose file up there and a shell script that you can run to start up your own open source Conger solution, and then start loading the policies into it to test it, or even create your own and try those out too. And if you're like me and you don't like reading code on a white background, then I've got the Vampire Edition out there for all you vampires that like to read on a dark background. That's the GitHub page link that you got from my title as well. So let's get into it. What is a security policy as code? Well, first we got to kind of talk about what is a typical security policy. I mean, it's one that's written for an organization to secure their physical and IT assets. We understand that. And typically, the way we've seen it in the past and today is it gets written onto a PDF file and then put into SharePoint or somewhere like that, and we assume all the humans out there are following directions, right? Well, or at least we hope they are until an audit finding comes around and we find out that maybe they're not. Typical security policy that we see normally today and in most environments is rotating passwords every 90 days. That's a simple one, you would think, but without the automation there, it could not get done. But what if that policy, that security policy, needs to be followed by a non-human machine? Now as we start to explore the world of DevOps and automation and things just kind of working on their own in a great interconnected manner, we need to start applying this policy to those machines that are moving at a quick speed, and not just the humans anymore. So here's where we start dealing with policy as code. And even further to that, using policy as code has its benefits. It allows us to apply that security policy that we used to just create on a piece of paper, hand to a human engineer, and hope that they implement. We can now apply that security policy as code directly to that server, to that VM, to that container, whatever the host or machine is, instead of, like I said, relying on a human to go and do it. And either they do, they don't, but we'll find out when the audit comes, right? Policy as code is followed by non-human machines in our instance in a top-down approach. So not only is it easy for a machine to read in that manner, but also it can be reviewed and audited easily by humans or auditors in your corporation. This has its benefits that we'll talk about in the next slide. So let's talk more specifically about what a CyberArk Conger policy is. Well, it's a machine authorization markup language that we love our acronyms over at CyberArk, and we gave this one MAML. It also establishes role-based access controls within Contra and applies those to machines as well as humans. And then also it gives you an easy way to audit your secrets access in your CloudBees Jenkins pipeline. So you can see what stages of your pipeline, what executors are accessing what secrets, and keep a separation of duties if you have multiple teams that you're dealing with. So back up to the MAML section, it's a YAML style formatting, so most of the file extensions will end in YML, but the syntax within is known by Conger. And it's easily readable by humans and machines alike for the same reason that I explained in the last slide, because not only do we want machines to be able to follow the commands that are laid out in our MAML policy file, but we also want a human to be able to easily audit it, and not a developer human. We want any human to be able to read it and audit it, right? As far as the role-based access control is concerned, this really gives us the ability to do a lot of amazing things. We can create a layer, which is essentially a group of hosts or machines that ease policy administration and oversight. And the layer is really where we can apply this policy and then accept the hosts or the machines that we apply an identity into the layer, so that they inherit the layer rather than having to create a policy for each individual host we're trying to apply an identity to. And we'll get into that more in depth in another slide. We are able, as you see, we just had a logo pop up on the screen. We're able to permit granular access to secrets, whether they're human or machine, and that's by granting them a machine identity, which is the logo you see there and that you also saw on some of Dan's slides. And you'll see in a slide here on the next one too. And what we do is we basically say, look, we don't care if you're human or you're a virtual machine or you're a container or you're a microservice or some script sitting over here. If you need access to these secrets, we need you to have an identity that we can trust, not only so that we can authorize you to gain access to those secrets, but so that we can say that we have an audit record of what or who accessed those secrets that we can trust to give to our auditors or to management or whoever wants to see what's going on here. And then we'll create entitlement roles that grant nesting roles for added granularity. The cool thing about that is entitlements allow us to basically do some awesome stuff with our policies. The policies model the infrastructure in terms of roles. So each policy is a separate role that we're creating, but then entitlements will come in at the end to connect those roles to the outside world and the business logic. So what you'll see us do is take something that is an internal process and connect it with something that's a public service. And I'll go over that in right before we get into showing off the policy and how that works. So we can easily audit secrets access in our CloudBees Jenkins pipeline by ensuring that that policy is the source of truth for secrets access in our pipeline. If we know that we have a policy as code that we apply to a host, I know for a fact that that host will go ahead and run whatever that policy as a code is, because it doesn't know that it can do anything else. It only knows to read code. So that policy now can become the source of truth of what this machine will end up doing at the end. And like I said, we can give identities to machines in Conjure, but they haven't evolved to the point of free will. So unlike humans, where I can give a human a task and he can decide whether he wants to do it or not, a machine doesn't have the ability to do that. So I can hand this policy as code to an auditor and say, this is exactly what's happening in my pipeline, because there's no human intervention, it's fully automated, and this is exactly what that machine is going to do. And by doing that, now you've opened up the floodgates for the auditors to pull their requirements anytime that they want, because now they have a piece of code that's sitting in a repository that they can access at any time. They're not relying on you to deliver those requirements to them, or they're not relying on you to answer their findings that they may, I have other things to do, everybody has other things to do. It's not our job to be answering audit requirements all the time. So let's empower the auditors to be able to research their own requirements, making them happy that they're meeting their findings on time, and making you happy that you have the freedom to do your job now. So let's take a quick look at the CyberArk Conger policy in perspective so that you can understand how this applies to secrets management for Conger. So first, we have our application that has a machine identity applied to it that authenticates over to Conger and says, hey, I need a secret. Conger will use the MAML policy to authorize that application's access. It'll see if it has the access, pass or fail, and if it passes and has the access, then Conger will go ahead and grab that secret information, and it will securely deliver the secret to the application through one of our many means of delivering that. One that was mentioned by Dan earlier in his presentation was Summon, our open source secrets provider, which is definitely my favorite way of getting these into my Jenkins pipeline. So let's take a look at our Ruby Gems policy. Today, what we're going to be doing is we're going to be setting up a Conger policy that allows a CloudBees Jenkins executor to clone source code for a Ruby gem from a GitHub repository securely over SSH, build it and test it. And then we're going to allow a separate CloudBees Jenkins executor that we call a releaser to publish it to the Ruby Gems public repository via the Ruby Gems API if the build passes. So I'll outline how we establish the entitlement role from Jenkins executors to Ruby Gems API, as well as from the Jenkins executors to the GitHub with private SSH keys. So those are the secrets we'll be storing, that API access to Ruby Gems, as well as the private SSH key to GitHub that we'll need for cloning. In the user interface, it's very easy to see. Definitely security persona type people enjoy the user interface, especially the dashboard. It's perfect for a security operations center, a quick glance at your most active secrets and such. But here we have our listing of policies, and the two policies we'll be dealing with today are our Jenkins policy and our Ruby Gems policy, since we need to set up secrets for both and the ability to grab secrets for both. In our user interface, once the policy is pushed down, that we'll take a look at the code here in a second, this is what we get. We get underneath the details section a description that we pushed of what this policy actually does. And as you can see, it says the policy for API access to Ruby Gems, public Ruby Gem repository. So that's easy. I know now that this is the policy that gives access to those secrets pertaining to Ruby Gems API access. And you can see here, highlighted in green on the role graph, we can visualize the entire thing. Anytime you see an arrow, just replace that arrow with is granted to, and you're good to go. So if I was reading this from the top down, we know the highlighted in green portion is my resource, the Ruby Gems policy we're looking at. And from the top, I have a Ruby Gems API users group that's granted to the Ruby Gems policy. And that policy is granted to the security admin user group because that's who loaded up the policy, was that security admin group. In that security admin group, at the foundation of this role graph, we have not only the admin user that I'm using, but also a couple hosts. So you'll see that even Conger has its own microservices that it rolls up into a user group. So not only can we add users into these user groups, but we can also add hosts as well into these, which we'll do in a little bit later when we set up some entitlements. So not necessarily needs to be a user. We can also have micro services here, like our LDAP sync and our secrets rotator, in case we need to use those. Now they have access through the security admin group. So let's look at it in code. And it's very easy from the top down. I like to use a big bang theory when looking at this type of policy as code. Anytime you see an exclamation point, which in my world is called a bang, we're creating something, okay? So at the very top here, we've got a bang and a policy. We've just created a policy resource. And that name is going to be Ruby Gems. So this is going to be our Ruby Gems policy going forward that we're going to create. And you can see below my blue arrow there that we have the description in the website that we've already seen in the user interface set up. Bang. Down here, we've got 3 secret variables that we're creating the namespace for: username, password, and API. All those are going to do is create the namespace in the secret section of the Conger database, but it's not going to populate those with any values. We would have to do that after establishing the policy and creating the namespaces. For now, they'll stay blank. Down here, we have another bang with the group, and we're creating an API users group here. Anybody that we add to this group after we permit its access down here will be able to access the secret variables that we created as part of this policy. So we'll have an empty shell of an API users group created through this policy that will permit read and execute access to all 3 variables that we've given in this policy. So if we take a look at the command line interface, somebody in operations out there might love a command line interface. Not me so much, so we're not going to spend a lot of time on it. But up here, we're just doing a Contra policy load, and then you can see I'm loading it up as the security admin group that I'm a member of, so that all of our different microservices are applied with the right permissions. And then I'm pushing up the Ruby Gems, and it comes back telling us that it created and permitted OK. We're good to go. So now we've got our Ruby Gems policy pushed. We know we have our API users group established and all of the secrets ready for the Ruby Gems API. Now we need to establish the same for our Jenkins policy. So for our Jenkins policy, if we take the same concept of reading the role graph as we did for the last one, and we start from the top down, we can see that we create a Jenkins secret users group in this new policy that's granted to the executors as well as the releasers layers, which we're about to get into. Everything else from the Jenkins policy level down is the same because we're going to push this policy as a Contra best practice as group security admin. So the same kind of below the green resource policies are going to stay the same as it did for Ruby Gems. And here's the policy. It's a little bit bigger because we're establishing a couple layers here, but there's a big reason why we need to do that. In CloudBees Jenkins, when we're dealing with CloudBees Jenkins from a Contra level, we're not really going to want to establish a machine identity on the master because the master is not really going to be doing anything. In a best practices scenario, it should be executors that are taking care of all the different tasks. So what we'll do is we'll separate those executors into 2 different executors and then create roles for them. That's what this is going to be doing here. So bang, we've got our policy created called Jenkins. We're ready to rock and roll. Description is just going to be a policy for Jenkins master and executors. I removed the masters because honestly, it's not necessary. We only need a machine identity on the executors that are going to be needing access to the secrets. Our Jenkins master doesn't need access to any of the secrets we're creating in these policies, so it's really unnecessary to have it even have any sort of association here. This is where we begin our journey into the awesome world of layers. We're going to establish 2 layers in this policy, starting with an executors layer. I consider executors the executor or the agents in Jenkins that are going to not only build but also test the Ruby gem for us in this instance. So we create this layer, which is just going to be an empty shell of a group that will be able to hold hosts as they get their machine identity from the host factory that we're applying to this layer here. And you can see the idea of the host factory is executors so that it's associated with the same executors layer. And the whole idea behind the host factory is to give an automated way for hosts who receive a machine identity to enter that layer. There's a whole process on how we utilize host factory to generate a unique host factory token that then as the machine, the executor comes online, it hands back the Conger. We can see that it's a token that we established and we can trust this identity going forward. So we accept it and bring it into the executor's layer. Once it enters the executor's layer, that's where we have this policy applied. So with the policy applied at the executor's layer, now anything that comes into this executor's layer will have the policy inherited by it. The benefits of that is, rather than me having 1,000 executors out there that I need to apply a policy to each individual one in a typical path-based scenario of access control, now I've got a 1 to 1,000 ratio where I'm admitting one policy, and as new executors come on board and get their machine identity, if it's one that's going into the executor's layer, who cares? Let's bring it in. It's inherited the policy, we're done. No changes to any source control management of that policy or anything. It's just immediately applied and you're off to the races. Now we made a releasers layer. I call the releasers layer so that we can distinguish between the build and test process as well as the publish process. So our releasers layer is going to be publishing to the Ruby Gems public repository so long as our build passes. And it has a host factory as well for the same reason that our executors layer does. And then finally down here at the bottom, we create a private key namespace secrets variable, which is going to hold the private SSH key that we're going to use for cloning and merging in GitHub, in our GitHub repo, using the GitHub user Conger-Jenkins. And then finally, we create a group, secrets users, and permit that group read and execute access to the variable, the private key variable. So we have a group that's created, an empty secrets users group as part of this Jenkins policy, that can read and execute the private key to SSH and clone and merge into GitHub repos. Plus, we created an executors layer for our build and test agents, as well as a separate releasers layer for our publishing agents. And we'll keep the secrets separated between the two. Here it is in the CLI. We've seen it before, Contra policy load, and everything loads up just fine. You can experience this in the GitHub open source version if you like that. And then finally, we get to entitlements. So the way entitlements work, it's a really cool way of being able to nest layers or users or other groups into additional groups to create a role. In this instance, a policy creates a group called Ruby Gems API users that can manage certain hosts. And then the entitlements define which users are a member of that group. So a policy would create a layer called releasers, which we just did in the last Jenkins policy. And then the entitlements will define which groups can fetch those API tokens for Ruby Gems. So in this instance, any of the Jenkins releasers that are added to that layer are automatically given the role of API users and able to publish and yank Ruby Gems off of the public repository for Ruby Gems. And then down here, we're doing the same thing, but if you remember in the last Jenkins policy that we pushed, we permitted the secret users access to that private SSH key in GitHub. And here we're adding the executors and the releasers as a member of that group so that it can have access to that private SSH key. The executors, because it needs to be able to clone and then build the potential release, as well as the releasers, if it does pass the build, it needs to be able to merge that branch into the master. And then here we load up the policy again, and I'm not going to spend much time on this because we've seen it 3 times now. So let's see what the policies created in Conger. We have our layers here, which you can see, our executors layer separate from our releasers layer, both created by the Jenkins policy that we saw. We also have the details of our Jenkins releasers specifically. I drilled down to show you what it looks like to be one of them. And here you can see it's a layer for Jenkins releaser hosts under the details section, and we get its own role graph. So every time we see something highlighted in green, that's the resource we're looking at. It's the perfect thing to just print screen and send to an auditor, or even just give an auditor view-only access to the user interface, and your job is done. And you can see here that the resource has 2 groups that is granted to it. So it has secret users as well as API key users, because not only does the releasers need to merge with master, so it needs that GitHub private SSH key, but it also needs to be able to publish to the public repository for Ruby gems if we so decide to. So it also has that granted to it as well. Everything else from there down is the same as we saw in the Jenkins policy. Here's our listing of groups from within the Contra user interface, and you can see the two that we created. Our secrets users is owned by the Jenkins policy because that's what pushed it, as well as the API users is owned by the Ruby gems users. If we drill down into one of them to take a look at what they look like, I chose the Jenkins secret users, and you can see it highlighted in green here in the role graph, and how it's granted into the Jenkins executors and releasers layer. And this is because both of those executors and releasers both need access to that private SSH key. The executors to be able to clone the code, as well as the releasers in order to merge with master. Everything from the Jenkins policy level down is the same as it is in the Jenkins policy. And then finally, we have our secret section here. You can see Contra comes with some already built-in, preloaded for our own API use. However, the ones that we pushed are the four at the bottom. We have our Jenkins private key that's owned by the Jenkins policy we pushed. We have the API key password and username that is pushed by the Ruby gems policy. And if we take a look at the details here, we can see we have a secret manager in the user interface that we can expand out and see the value, which is blank for now, and add it in if we want to add a value to that secret. But we also see the resource permissions here. We can see the Ruby gems policy is the owner, as well as the API users group has execute and read on it. And if we scroll down even further, we can get audit events. And this is evident on every page throughout the user interface. You see that resources audit events, or you can go back to the dashboard and pull full activity. Finally, we get to our Jenkins file. And we start off with our first stage in our V2 pipeline, where we're assigning the executor V2 label to it so that we use our executor V2 agent. And then down here, we're going to start our test stage. And what we do with the Groovy DSL is we build everything in a shell script where we make sure that the, in this instance, GitHub private SSH key, as well as the, well, it's just the private SSH key in this case, gets pulled down using summon into the shell script and passed over that way. So we're utilizing summon in this shell script and then wrapping it in the Groovy DSL, and then printing out the test reports here for an actual human to be able to review. If everything passes and everything's good, we get to our second stage where we apply the tag releaser V2. So now we're using our releaser agent here and separating that duty. And this is where we basically figure out if we want to publish the Ruby gem. If it passed and everything is well and good, then we're going to merge with our master branch, which uses the private SSH key pulled down from Conger. And then we're going to ask a quick question where somebody has 5 minutes to answer. Do you want to publish this to Ruby gems? They have 5 minutes to take a look at those JUnit XML reports and make a decision. Down here is where we actually have our shell script to publish. So everything is protected using summon and not hard-coded in here. So that's how we secure those secrets and remove them from management. And if all is well and good and everything is published to Ruby gems, we've basically just taken care of the 4 security challenges specific to CI/CD according to Dan. If you remember them correctly, they were unmanaged secrets and credentials, right? We solved that by applying a policy that does manage these secrets and credentials and the authorization to access them. The master servers don't have too much privilege now because we completely avoided any privilege on that master server altogether. We granted the identity to the executors or the agents, avoiding the need to give any permissions to the master whatsoever and removing the privilege from it altogether. We were able to create it, the policy as a code, and check it into source control in a way that we can duplicate this for different platforms as well as different environments. So this could be a development environment today and a QA environment tomorrow. But with policy as code, we can easily take the Ruby gems YAML file and reapply it to be, for NuGet. And now we've got a NuGet YAML file that we just need to store the API key, username, and password for that and push that policy in. So now we've got a template going forward too that makes our jobs a lot easier. And then finally, the lack of audit and compliance visibility is no longer an issue. We've got identities applied to our executors. We have running records of what secrets they're accessing, and we know exactly what secrets they can and cannot access based on the policy as code. So our auditors have a real source of truth that they can look at, and as long as there's no human interaction dealing with the automation, then we have nothing to worry about with anything being injected in there. So hopefully you enjoyed this. I know I kind of probably ran over by a minute or so, but I definitely appreciate the time everybody's given me, and please don't forget to try it at your own pace, on your own time, and I believe that everybody will love the concept. Thank you.
All right, thanks everyone. We are a little over on time, so we're going to have to be logging off now to be respectful for everyone. But I do just want to thank all of our presenters for a really information-packed session. I want to let everyone know in the chat that I put a link to our post-session survey and my email address, so if you had any questions that we weren't able to answer during the time, feel free to just pass them right along to me there. We will be getting you the recording and the slides within the next few days, I believe, and we hope to hear from you all soon.
Oh, hey, Max, before you shut down, so we had a lot of questions, and I answered a bunch of them, but there were one or two that went unanswered. So are we going to circulate a a Q&A sheet or something to everyone?
Yes, I'll collect the questions and we'll come up with something to do for everyone.
Okay, great. A lot of good questions. So thanks for that, everybody.
Thanks, everyone.